Good afternoon, everyone, and welcome to this session. It's a tough ask following Raghuram. This is a very interesting session, but we'll try to do our best. My name is Kalyan, and I'm accompanied by my colleague Vaishali, who's the expert here. And we wanted to cover, I think, which is a follow-up to Raghu's session, right? He talked about the overall system. We are trying to go deeper into a very critical part of which is around if you have agentic Gen AI and agentic platforms, how do you observe, monitor, evaluate, what are the challenges, what are the tools, and so on, right? So that's the goal. And about us, my name is Kalyan. I currently the India head or MD for a group of AI companies, Symphony AI Group or SAI Group of companies, which is a global enterprise leader, right? It's one of the largest group of companies. It comprises of number of companies. There is some healthcare companies called GetWell Networks, very successful. There is RhythmX, and we are also building a autonomous agent and AGI platform as a product company, a horizontal company called JazzX, and it's an SA group, right? Symphony AI and all these other companies I talked about. We are very big on open source. We have a platform called Eureka, which is a data and AI platform that's end-to-end open source based, which is platform, cloud agnostic, LLM agnostic, and so on. And so we are very passionate about it. And even in the past, I was there for about 2 years at Intuit and 5 years at Hitachi, where again, I was heading the India site and engineering head for development platforms, AI, ML, Gen AI, SaaS, and so on. And here again, fortunately, we were very big on open source at Hitachi and Intuit. We contributed a lot, and the intent is to continue that. So I'm very passionate about open source, and yeah, I'll hand over to Vaishali, who's the expert in this area. So yeah.
Yeah. I'm Vaishali. I have currently working with GetWell Networks, part of SAI Groups, as principal engineer. I have worked previously with MyCom and Hitachi as an architect, focusing on performance, QA, and observability. I have overall 15 years of experience in testing modern frameworks, performance tools, and observability. And I'm into observability and testing of testing and evaluation of AI and ML applications recently.
So yeah, the agenda in brief is basically as I said, right? What is the motivation, right? Why do you need evaluation, observability? What is so different in the AI observability, right? And what are some of the best practices? What were the challenges we faced? And how did we overcome those? What are some of the best practices? And this is our own experience and based on published case studies and literature from the industry, we're trying to share all of that. And again, the content is huge. There's a number of platforms. So we are trying to stick to what we are experienced in, and this is a sampling of it. There's a lot more content, so we'll definitely, this is already uploaded to the site. So we would request you to, go through the slides as well, where there's a lot more content. And right after this session, we'll be adding the references as well, so that you can, you'll get pointers to further reading that you can do. Right? So what is the motivation here, right? So if you look at the whole Gen AI evolution, right, it's been a radical transformative change which has impacted the industry in a big way, and that's also been evolving very rapidly, right? We started with LLMs, right? And then we added RAG, right? And then again, there was a vector search-based RAG, but then we realized that we need knowledge graphs or graph RAG. We need agentic systems, agents. These agents can become autonomous, in which case there's a lot of learning involved. Then you have hybrid RAG and so on, right? And even in agents, right? I mean, one were LangChain like orchestration systems, then there were LangGraph, right? Or other systems, right? The similar systems. So you have hierarchy of agents communicating with each other, calling tools, and so on. So this makes it extremely complex. And as it is, as we know, LLMs are computational intensive, very expensive, and agents are even more so, right? So cost becomes a factor. So how do we monitor all of that? How do we troubleshoot issues? What are some of the extra things, right? And then there's a whole challenge about testing things, right? Because these are all non-deterministic, right? So how do you really test evaluate, and is it that just the traditional testing, is it enough, or do you need more, right? So we look at all of those things. What kind of evaluators we need, what are some of the important, and then Vaishali will cover some of those. And this is, for example, again, this is borrowed from Raghuram, but this gives a sense of it, right? So you have a prompt, right, which is again a whole set of attributes, right? There's context, there's examples, and so on, right? And then when you are actually executing on this, right, then you're doing calling tools, you're doing semantic search, you're doing structured data retrieval, and that actually involves vector databases, knowledge graphs. You're doing a lot of tools. You may typically use a lakehouse, etc., for storage. Agents are critical part, and all of these are interacting. And you could have a problem at any of the points, right? Both in terms of correctness or in terms of performance, right? So it becomes extremely challenging, and without a right observability, evaluation, and testing frameworks, you're lost in the dark, right? Something is going wrong and you don't know what's going wrong, right? Or you're not getting the right results, right? So, and this whole space has evolved. There's some very, very powerful open source frameworks and tools, and there's a lot of convergence happening, which again Vaishali will cover. So over to Vaishali.
So, yeah, observability. So, observability is not new things. We had traditional observability. Yeah, traditional observability even before AI observability. So, what AI observability is different from traditional observability. Like what we were doing in observability, we were monitoring our application using traces, logs, metrics. So, when it comes to AI observability, we are doing the same, but it is for AI and LLM based applications. So we use metrics, traces, and evaluations. Here, evaluation plays a very major role across their life cycle. So recent trends has been the convergence of these capabilities that are manual and auto instrumentation. So when it comes to AI observability, we can say, we can add one more as a pillar: metrics, logs, traces, and evaluators. So what do we observe? What sort of metrics we observe? So the first one would be agent level metrics, basically our prompts, responses, tool callings, and model settings. Storage and memory level metrics, search queries and retrievals, latencies, and failures. And framework level tracing. So when we are using like these frameworks like LangChain and LangGraph, so multiple tool callings would be happening. So those sort of metrics and agent data passing metrics, all these things we'll be observing as a part of AI observability. So there are a lot of open source tools which is available in this space. So today we'll be talking about few of it. One would be Langfuse, OpenLLMetry, ML flows. So as I mentioned, evaluations plays a very major category either in testing or in observing LLM applications. So there are two categories of metrics. Human-centric evaluation criteria, these are subjectives, where these are typically manual scoring, or we would be using another LLM to judge the output of one LLM or one system. So few of them have listed here, but the maximum used one would be correctness, whether my output is based on the ground truth. Relevance is the output on the contextually appropriate, and coverage is the generated text is covering the entire, is it answering all the parts of my query? And automated evaluation metrics is like computed using tools, embeddings, or reference data. Few of this we can look at next slide. So this is a simple and easy way of understanding how this precision, recall, and F1 scores, few of these metrics has been generated. Like we can consider there is like one of the query would be, what are the prompts, what are the symptoms of diabetes? So my expected references has 5 symptoms, whereas my LLM output has 4. But out of 4, all the 4 are correct. So my precision score would be 1. Whereas my recall is like 5 are expected symptoms, which is a reference input, whereas the LLM mentioned 4, which are correct, so the 0.8. So F1 score is basically an average of precision and recall.
So we'll be covering a few tools, and and one of the things, as I think we highlighted in the earlier slides, right? The tool started with differing strengths, right? And one of the things that we are seeing is quite a bit of convergence, right? There were tools like Langfuse, right, who were very good with tracing. There were others which were Ragas, for example, right, was specialized in evaluation, and there are other tools which were more into experimentation, right, like you know. I'm forgetting the name, sorry. So, yeah, so there are different tools, and now there is a convergence happening. Similarly, pretty much all of the tools support automated instrumentation, but you can do something manual if you want a fine-grained control in terms of what should be instrumented, what's not, and so on, right? And sometimes that can also be configurable, right? So it's a convergence happening. So one of the very promising tools is MLflow, and the big advantage with MLflow is the fact that it's an end-to-end tool, right? For the complete MLOps lifecycle, right, starting from the model versioning, the experimentation that you're doing, and so on, right? We are looking at model serving, and then there is the whole operations, right, in terms of monitoring and performance and observability. So it covers the complete life cycle. So you have one tool that does it all. So that makes it very appealing and very compelling option. And so there are some very powerful evaluation capabilities. So you can do a very simple one-line eval. You can have a single API that actually can drive a lot of different evaluations underneath. There is rich visualizations. You can have a lot of custom metrics, and then you can plug in different evaluators, right? That go beyond what's there out of the box. So very, very powerful. And again, that's the power of Databricks behind it. And then you can do model data set function evaluation. Function is essentially if you want to do something quick with the Python functions. And the tracing again, right? Observability, they've taken tracing, extended that to Gen AI with semantic conventions and so on. And the good thing again is that this supports a full stack observability, right? So essentially, the, what MLflow does is that the traces can be returned to any backend that you want, right? So the exporter can write to the backend or store of your choice, right? Data store. So that's again very flexible. And it supports a whole lot of frameworks and LLMs. So again, very powerful. So as I said, right, I mean, it's a very strong community. It's an end-to-end platform, hotel. The one negative is that a lot of these capabilities are fairly new. So they're not as mature and robust, but there's significant improvement over time. So we expect that over time, these will become much more mature as Langfuse is, for example. OpenLLMetry, it's much more basic. The focus is a lot narrower. It's around observability, tracing, and some of those things. But OpenLLMetry has been a pioneer because some of the other tools were fairly siloed, right? And they were not giving full stack. But the OpenLLMetry example is that you have OTel with a lot of powerful capabilities. Can I extend OTel to support, right? To support AI observability and agentic observability, and they did a great job. And again, the advantage is that you have your own observability systems for logging, tracing, etc. This simply adds to that, right? It doesn't create a whole new system, and so you can write to the same backend. And that other thing they've done is that they've extended the OTel, attributes and others, right? So that they are, they're relevant for AI observability. And in fact, the semantic conventions, which we'll cover in the later slide, which are a part of OTel, right? Which essentially standardize everything. That's been extended to support agents and Gen AI and so on. And in fact, a lot of those initiatives came from OpenLLMetry, and the OTel folks accepted a lot of it with some changes and additions from the other vendors. So OpenLLMetry, again, the pros are that it's very good with Intel, so you can build on what you have. And full stack observability is extremely critical, right? You cannot observe your AI in isolation, right? It needs to work with all of the other systems, the microservices, the UI, your data pipeline, all of that together. That's what gives you a lot more value when you're doing troubleshooting and root cause analysis and automated remediation and recovery, right? The cons, as I said, it's fairly limited. There's not too much of evaluation and other capabilities, for example. And we'll have Vaishali look at Langfuse, and we'll have a very brief demo to just show the capabilities.
Thanks, Kalyan. So Langfuse is again an open source observability and evaluation platform for LLMs agentic application. So one of the best in LLMs and agentic space. So fully functional, matured, and production grade. So it has support, I mean, it's completely open source, and it supports multiple LLMs and multiple frameworks. Customizable dashboards and built-in dashboards are there, integrates with CI/CD pipelines, provides end-to-end tracing from agent flow, prompts, traces, and other metrics like latency, cost, everything would be, is there in one place. Cons is like, as Kalyan mentioned, it's limited with OTel masking, OTel making, and full stack observability challenging. The thing is like, as of now, it is like supporting only LLMs and agentic apps. So if we are looking at the full end-to-end observability, so there would be two systems here. So stitching between regular traditional observability and Langfuse, there is some effort. So let me take you all through a simple demo on Langfuse, where I'm just taking a simple applications with multiple toll router. So we'll be looking at dashboards, few of the evaluation metrics, and model cost environments data. So if we look at this one, we have a end-to-end trace. So my first component, query router. Query router is calling tool router. Tool router is selecting a tool. Based on the output, insight is being generated. So this is one of a simple application which have taken. And if we see, we have this few of the scores. So these scores are based on a few of the evaluation metrics which has been set, which is like LLM as judge. Whenever this executes and when there is a traces, this evaluators will be applied and the scores would be generated. So if I see here, I'm considering one for the correctness. So here my ground truth is like tool router output. So if my generated text has a tool router response, based on that, this score has been generated. So here I'm just looking at one more trace where, how traces has been helpful for debugging our applications. Like here in one of the traces, I have few errors. So if all the error messages and the error messages, status messages, and at which step it has failed, those level of information, it will be helpful for debugging. So coming to the dashboards, it supports built-in dashboards. So we'll have the trace count, model count based on the models, scores which has been set, and it allows us to create custom dashboard as well. So usability-wise, compared to other tools, it is customized and it's in handy.
Yeah. 1 second. Sorry. Yeah. Okay.
So in case of testing of AI and LLM applications, testing and observability goes hand in hand. It is not like, we all know, like traditional testings where it's input versus output. If my input versus output, like if it is matching our expected conditions, it's like my app is fine. But what makes AI and LLM testing different is like, it's non-deterministic behavior. Basically, it's like LLMs may produce different outputs for the same inputs, and multiple valid answers could be applicable, and small prompt changes might change the entire response. So here our goal is not on focusing the expected versus actual versus expected. It's more on quality, consistency, safety, and usefulness of the application. And how do we do it? So we focus on automated evaluations. Basically, we use evaluators, manual annotations, golden data sets, and semantic comparison capabilities provided by few of the test frameworks which would be used for achieving this. So when it comes to AI and LLM testing, still traditional few of the testing still applicable, like functional testing, behavioral testing, exploratory testing still makes sense. And the regression testing, here in regression testing, we will be using golden data sets, which is used to evaluate our responses based on the models and the prompts. And few of the testing which would be specifically for AI and LLM applications, like A/B testing, advisory testing, and evaluations, we already spoke about it, and agentic flow validation, where we'll be validating the tool selections, retries, and fallback behavior, how application behaves in these scenarios. So in case of generative AI, it's basically, we can consider it as kind of our LLM, where mostly focus will be on our prompt testing, golden data set, basically a regression, and LLM is used for evaluation and metrics. We use observability and tracing to monitor it. When it comes to agentic application, there are few more validations, additional validations which needs to be done. Planning, verification, tool execution, whether my agent is calling the exactly tools based on the instructions, recovery and loop testing, chain of thoughts, end-to-end testing. Along with all these things, performance testing is required. To make sure that how application behaves in the load and stress, like if n numbers of users are accessing the application at the same time and using a number of chain of thoughts. So how the application behaves and what would be the response time and response time from the LLMs as well. So one of the best testing tools or testing framework currently we are looking at is DeepEvolve, which is an open source testing framework for evaluating LLM outputs. It has built-in key features like multiple 30+ built-in metrics. We can create custom metrics, supports end-to-end testing, synthetic data generator. Most of the cases when we started, we don't have a data sets to test. So it helps in creating synthetic data generation, security and safety checks, benchmarking, and it can be easily integrated in CI/CD pipelines. So we can run DeepEvolve test as a part of our release process. So this is becoming, one of the strong candidates for building a production-grade LLMs.
So we'll wrap up. And so one of the things I talked about that was critical to do all of these was semantic conventions. And again, the whole idea is that you need to have the same nomenclature, hierarchy, and structure, right, for the data. So that if you're saying, for example, one of these, right, like GenAI agent description, right, it should be the same. GenAI agent ID, that should be the same. So, and that's something that OpenTelemetry was already following for the standard pillars or for traditional observability. This has been extended for GenAI and agentic systems. And essentially the advantage is that we have a consistent meaning interpretation. It's highly interoperable. You can correlate data very easily, which is extremely critical if you want to do root cause analysis and so on. And it simplifies the analysis, right? And so for the GenAI semantic conventions, right, these are primarily 4 pillars: metrics. Again, these are, I'll just listed some examples, right? So AI.line.token usage, right? So, and typically these are essentially, it's a, there are organized hierarchically by domain and scope, right? So that's what you'll see here. Events, it's primarily GenAI choice, and this has a lot of attributes, and then you can also have custom events. Model spans, again, these are some examples. What is the operation name? What is the system? What is the conversation ID? And similarly, for agent spans, there are some agent-related details, agent ID, agent name, and so on, right? So these are some examples. And again, it's far too complex, and this is again being extended significantly, but these are some of the things that have been agreed upon. So now, by following these systems, regardless of which system you use, they'll interoperate with each other, and then the attributes and the will have a very consistent and clear meaning. I'll quickly wrap up by talking about when you talk of observability, right? One of the key aspects to it is I'm looking at metrics, events, logs. I'm doing it for Gen AI systems. I'm doing evaluations, right? But at the end of it, right, I'm running a system. I need to do my root cause analysis, right? My system is performing slow, or it's very expensive, or there's a downtime. What caused it? How do I troubleshoot it, right? So one of the uh, things that we are building, right? A very, very key, I think, trend recently is the incident recovery agents, right? And this is also an example of dog fooding, right? So we are actually using a hierarchy of agents to observe agents, right? And completely end-to-end agentic systems, right? That's what we are doing here. And so essentially the idea is again, right? We are feeding logs, metrics, traces, and other change events. We have the incident or the RCA database. So we are looking at all the data, we are getting failures, and then we are trying to correlate with what happened in the past. And Gen AI helps us in two ways, right? We have a vector database where we can do vector search. We also have agentic RAG, we can make external calls, and we can also look at and knowledge graph, right? Because from the traces, you can construct a dependency graph, and you can overlay a lot of other information to create a knowledge graph, right? This makes it extremely powerful. So I can localize the problem, and then I can look at the logs and other things. I can correlate them, look at the prior failures, and based on that, I can come up with a probabilistic root cause. And in many cases, it may be deterministic, in which case I can probably do a remediation, right? And so the idea with incident recovery, it again mimics your standard SRE support system where you have ops teams with platform teams and different teams coordinating with each other. Now we have agents doing the same, relying on the whole underlying information, right? So this is an example of where, and then they talk to LLMs to figure out certain things. There are agents, there are tools and everything, right? So this is a great example of as I said, dog fooding, right? Using our agentic infrastructure to monitor, troubleshoot, remediate any issues with agents. I'll skip this in the interest of time. And this is the last slide. So some of the best practices, right? So one of the things we have seen is that quite often when you're actually doing observability, it can become very expensive. So you may need to truncate, for example. And again, OpenTelemetry is a very good framework where you have, the collector has a processor, right? Where you can do truncation, you can do redaction, you can do so many things, right? You can drop certain data, you can aggregate and so on. So truncation is something we have found useful. Masking redaction is important. And here again, there are multiple approaches. You can do it at the hotel level. Again, there's a redaction transformer, right? Yeah, so that's one example. And similarly, Langfuse and other tools also let you do masking. Masking is extremely important from compliance and security, and for those reasons. Feedback is critical, and not all feedback needs to be human. Sometimes systems generate feedback, and from that you can actually generate a lot of auto-labeled data, which can be used further for training. And that's one of the things where observability becomes important, right? In fact, at JazzX, right, we are actually building AGI systems with autonomous agents that can learn by themselves, right? And without observability evaluation in place, how do I know the learning is working? Unless I see an improvement, right? So that's why evaluation observability becomes important for these advanced systems, even more so. I'll skip mostly, and I think use async. I think that's something because quite often the overhead can be huge, and you may have to do sampling, etc. Tail sampling is better, and that applies to Gen AI systems as well. And typically, OTel instrumentation, which is decoupled, is better than frameworks built-in instrumentation because that creates bloats and you don't have much configurability in place. Thank you. Thanks, everyone. I hope it was useful. We can take a few questions, and the rest after this, we both are here and we can talk to you offline. But if there are any questions, can Vaishali. Okay, looks like everything was clear. There are no questions. So, but we are available offline. If anybody has questions, you can talk to us offline. Thanks a lot. We really enjoyed it. I hope you found this useful.